Alright, hello everyone. So in this video, I'll be showing you how to train custom YOLOv4 object detector using Google Colab. So I'll also be sharing a link to my Medium article on this in the description below. You can find a much detailed explanation of this entire process in this article. So go ahead and check it out. Okay, so let's begin with the process. So first, to begin, I'll be giving a link of my Colab file in the description below. So just click on it, open it in your browser, click on file in the menu bar and click on save a copy in drive. This will open up a copy on your browser. You can now use this file. So once this file is open, and you can connect to the Google Colab VM and then click on, once you're connected, just click on runtime, change runtime type, select hardware accelerator as GPU, click on save. That's it, we're ready to go. So I've devised 12 steps for this entire process of training a YOLOv4 detector. So you can just follow these 12 steps. Okay, so for this I'll be cloning the Darknet repository in a folder on our drive, on our Google Drive. So okay, let's begin. The first step is to create YOLOv4 and training folders on your drive. Create a folder named YOLOv4 in your drive. Okay, so let's create a folder named YOLOv4. Okay, next step, next create another folder named training inside the YOLOv4 folder. This is where we will save our train weights. Okay, so this path will save our weights during the training process. So create a new folder inside this and name it as training. Okay. Now next step, mount drive, link your folder and navigate to my drive YOLOv4 folder. So just click on this. Select your account, allow, copy this and just paste this and press enter. This will mount the drive, link your folder. So you don't have to type this every time. You can just write / my drive and that will be enough, and then navigate to my drive YOLOv4 folder. Okay, so it has been done. And next we will clone the Darknet git repository in this folder. This will take a moment. Okay, we can also, now since we have a drive mounted, we can also view our files on Google Colab in the file section. So just click on G drive, my drive, YOLOv4, and there we have it. We have Darknet repository cloned in this. You can also view it in your drive. Okay, so now moving on to the next step, create and upload the following files. We need these files to train our detector: labeled custom dataset and a custom CFG file, obj.data and obj.name files, and lastly process.py script file to create train.txt and test.txt files. I will be explaining this later on, what these files do. So I have uploaded all my custom files for mask detection on GitHub. You can just go over there and download this. The YOLOv4 folder here has these 4 files, and I've shared my label custom dataset on this link. You can download it from here. Okay, so first step, upload the label custom dataset obj.zip file to the YOLOv4 folder on your drive. So if you have labeled your images, suppose these are the images that I wanted to label. I labeled them, and the output YOLO label files, the text files are here. Now put all these files in the same folder. Okay, so for this file, this is the labeled YOLO format text file. Okay, so create a zip file for it. Let's add to archive zip. Okay, let's create a zip file for it. I already had the zip file in this over here. Okay, so upload the zip file to the YOLOv4 folder on drive. Upload this file from our desktop. Okay, this might take a moment. Okay, to know more about collecting data and labeling, you can read my Medium article on that. I've made another Medium article for labeling process. Okay, so it has been uploaded. Next step, create a custom config file and upload it to your drive. Download the YOLOv4 custom.cfg file from darknet/cfg directory. You can download it from here simply. This has all the config files for all the versions of YOLO. So at the moment we need this one, YOLOv4 custom.cfg. Let's download this, and we have to make a few changes to it. We have to make the following changes to it. Change batch line, batch to 64, this to 6416. Change line maximum batches to 6000. This is the minimum number that we need. I have two classes, so I'll be changing this maximum batches to 6000, and then I'll be changing the steps to 80% and 90% of it, that is 4800 and 5400. Then okay, and change network size, width and height to 416. Change both these to 416, and then change line classes to 80 to your number of objects in each of the three YOLO layers. And lastly, change the filters to your number of filters. Okay, so this is the formula which is used to calculate our filters. So for this number of classes plus 5 into 3, I have two classes. 2 plus 5, 7 into 3, that's 21. So if you have two classes, then write filters equals to 21 in all of the three convolutional before each of the YOLO layer. We have three YOLO layers, so we'll have to do both these steps 3 times. Just go to the bottom. This is the first and last YOLO layer. Change your class to 2, and just above it change this filter to 21. Then find another YOLO layer, change this classes to 2, the filters just above it in the convolutional to 21, and then the last YOLO layer, again do the same over here, and that is it. We are done with editing our custom config file. Save it and upload it to this drive. I have put all my files in a folder on YOLOv4, so I'll just upload it from here. Now the next step is create your obj.data and obj.names files and upload them to your drive. So this is how your obj.data file should look like. It will contain your number of classes, part to your train and test.txt files. I'll be explaining what these do later on. And then it also have a part to your obj.names files, which has all your classes and their names written in it. And then lastly, the backup, where we'll save all the weights during the training process. Okay, so you can upload these two files to a drive. Do the same thing. Upload these files, and then the next step, upload the process.py script file. Okay, so what this process.py script does is it creates the train.txt and test.txt file that I was talking about earlier on, where the train.txt file has paths to 90% of the images and test.txt has paths to 10% of the images. So upload this process file to process.py script. Okay, so all the files have been uploaded, and we can now move on to the next step. Make changes in the make file to enable OpenCV and GPU, and then also set CUDNN half, and LIBSO to 1. Okay, and then finally run the make command to build Darknet. This might take a minute or two, so just be patient. Okay, so once this is done, let's move on to the next step. Okay, so the seventh step, copy all the files from the YOLOv4 folder to the Darknet directory. So basically, I'll be copying all these 5 files to the Darknet directory. So first step is optional. Just doing this to clean the data in CFG folders, because this has too many files in it. So I'm just doing this to make it a little more cleaner. Run this. So now this will delete all the files in the CFG folder and the data folder. Just make sure you don't delete this labels file folder, as we need this for making our labels during object detection. So do not delete this. Okay, so unzip the obj.zip dataset and its contents so that they are now in darknet /data folder. So unzip my drive, use this command, just run this. This will unzip this into this data folder over here. Okay, so for the next step, copy the custom CFG file to the CFG folder. Okay, so the CFG folder has been copied over here. You can double check all the changes that we made. Okay, that's fine. Again, do the same for the obj.names and obj.data files. Copy them to the data folder. We have them here. And lastly, copy the process.py script file. And that's it. We have the process.py file over here. Just run the process.py file. For the next step, this will create the test.txt and train.txt files in the data folder. Just open them to verify. I had 1510 images total, so the 10% for that is 151. So that's perfect for test.txt, and for train.txt it should be 1359. So yes, it's 1359. This is also fine. We can move on to the next step, that is download the pre-trained YOLOv4 weights. Just click on this. It is better if you use pre-trained YOLOv4 weights. You can also start train your model from scratch, but that will take a longer time. This is the better option. Okay, so lastly we move on to training. So to train, just use this command, darknet detector train data obj.data. Mention your path to the obj.data file and the path to your CFG file, and lastly this is the weight files that we pre-trained weights file that we just downloaded, this one. So, and then this is for mean average precision. Just click on this and this will start the training process for you. Now for optimum results, make sure the average loss is between 0.05 and zero point 0.3 for a good detector model. But you can stop training if your average loss doesn't show any change for a while. Now what this does is what this saves the weight files every 100 iterations as YOLOv4 custom last weights in your training folder. Right now we have just gone through 10 iterations, so I'll wait and come back to you. Okay, so this might take a while. Okay, so if you get disconnected or lose your session for some reason, you don't have to start training from scratch again. You can restart training from where you left off. You can just use the weights that were saved last. So what this does is this saves weights every 100 iterations as YOLOv4 custom underscore last dot weights in our backup drive over here, as you can see. So since right now we are at iteration number 137, this has already saved this one time. Okay, so suppose if we get disconnected for some reason, you can just reconnect and you can follow these steps. If you get disconnected, to restart training, just run steps 2, 5, 6 and then run the following command. So you don't have to run all these steps as you've already done these. Also, we have all the files that we need for training on our drive. We copied all the files into this Darknet directory, the CFG folder inside this CFG, and likewise all the other files in the data folder, obj.data, obj.names, both these text files. So basically we have all the files that we need for training in the Darknet folder on our drive. So that is why we don't have to carry out any of these steps again. So all you have to do is just run steps 2, 5 and 6. Step to mount your drive and do the same thing. Copy, paste, enter. Okay, so it has been mounted. Next step was fifth step, make changes to the make file. You have to perform these steps 2, 5 and 6 every time you get disconnected. Otherwise the Darknet executable won't work. Again, this might take a while. Okay, so once this is done, let's move on to the training section. So to restart your training, this is what we have to do. Run steps 2, 5, 6. We've already done those, and then run the following command. This is basically the same command as the previous one. We've only changed the weights over here, so you don't have to train this from scratch. You can use the weights that were saved last on your drive, these ones. So give the path to this and then run this, and it will start training again. So it's as simple as that. So you can use this This is a simple hack just to avoid being kicked off Colab VM. Just click this, copy this, press Ctrl Shift I, go to console, paste this, press enter, and that's it. But the thing is, training YOLOv4 takes really long. It might take a few hours, and Google Colab only allows a maximum duration of 12 hours uh, at a time. So you will get kicked off at some point. So you can come back later and again restart training using this process. And then once it is all done, I'll pause this and come back later once all the 6,000 iterations have been done. Okay, so training has finished. As you can see, this last iteration 6,000 we gave as maximum batches. So at the last iteration my average loss reached around 0.68. For a good detector model it should be between 0.05 and 0.3, but this will work fine because the dataset that I labeled is not the best. We can use more images and probably reduce this average loss, but this will work fine just for demonstration purposes. Okay, so let's move on. The next step is to check performance. Define helper function, I am sure. And okay, so there's two ways that how you can check performance. One is using the training chart. So this only works if the training does not get interrupted, but since I got disconnected, this will not work. This will give error. So okay, as you can see, there's no output for this, but there's another method we can use by checking the mean average precision. Use this command for all the weights. So suppose these are the weights that are saved after the training process has been finished. First it saves these weights every 1,000 iterations, and then you're looking for best weights, final weights, and last weights. So you can check the MAP for each weight to check which is the best MAP. Okay, run this. Okay, so as you can see, so I mean every precision at 0.5 is 0.98. So okay, this is how you can check the MAP for all the weights and find out which weight file gives you the best result. I'll just use the best weights file, this one, for testing my object detector. So that is the next step, test your custom object detector. For that, first we have to make changes to a custom config file. So we have a config file in the CFG folder over here. So as you can see, for training, the batches and subdivisions we set 264 and 16, and for testing, as you can see, it should be 1 and 1. These have been commented out. You can just change it over here, comment these and uncomment these, or you can just simply run this code. That will do it for you. Okay, so I just changed these two values to 1. Okay, so next we'll run detector on an image. So for that I have an image uploaded on my Google Drive. So I've created a folder for images and videos where I have all these image files for testing, and the same for videos. You can upload these. Okay, so to run detector on an image, use this command: Darknet detector test location to your obj.data file to your CFG file. Next part to your weights. I'll be using the best weights which I mentioned earlier. You can use any one of these which you find has the best MAP. So I'll be using the best weights, and then the part to the image you want it to run detection on, and then this threshold, this parameter sets the minimum required accuracy for object detection. So you can set this to 0.3, 0.5 or 0.8, whatever minimum accuracy you need for your object to be detected. So okay, so let's run this. Okay, so okay, as you can see, this has run detection on this image. The first image that I have over here, this one. Okay, so you can see the result is pretty good. Now it has predicted all these masks with almost 99% accuracy. It has even predicted the one with Mona Lisa wearing a mask behind with 44% accuracy. So that's really good. Now let's run detector on a webcam image. So this is a simple snippet from Google Colab itself for camera capture. I just use that code, just simply that code, and then for the last two lines I've added the same code that we used in the previous command, this one. So that is it. Okay, so okay, let's capture the image and let's see the result for it. Okay, as you can see, this is also pretty good with 98% accuracy for this mask. So my dataset mostly has close-up images, so it will give you really good results for close-up images. It's the long shot images that will have a problem. Now let's run detector on a video. I have a few videos uploaded on my drive. Okay, so I'll use a few videos. Let's use third video. Okay, so the command should be like this. Again, detector demo, again obj.data, CFG file, part to your weights, then this is the part to your input video file, and then the output file name where you want your output file to be saved. I want it to be saved the same location as final results, final result.avi, and then run this. As you can see, this is already running detection on the video. This might take a while depending on the length of the video. So I'll be back. Okay, so it has finished detection on the video and it has saved the video as final result.avi. Let's wait for it to be processed. Okay, now we can view this. You can see The output for this is also pretty well, I might say, considering the data set that I had. This is working really nice. Okay, so for the last step to run detector on live webcam, you can use this code. So I have adjusted this for my custom CPG file, my obj.data, and my weight file for mask detection. So I'll just run this. And let's see in the video if it can detect mask or not. And you can see it can detect mask pretty well. Let me take off my mask. Yep, so I can working very nicely. Let me put my mask back on. Yep, it is showing me mask. Let's stop this. So okay, that's it for this video on how to train your custom YOLOv4 detector using Darknet on Google Colab. So if you like this video, please click on the like button and make sure to subscribe to this channel. And okay, I'll see you in the next one.